here? Should be streaming. There we go. Cool. So we have some submissions for Project 5, but I figured next week that could be the day to submit like Project 5. And it's a rough draft, so kind of like revisiting what we did in Module 1, like what kind of proposal, if things changed, or maybe there's updates of like what you want to do, and that's fine. But we're coming in hot to the end of the semester and kind of the end of stuff that I'm telling you that you have to do, and into stuff that like, wouldn't it be cool if this class was more focused on X, Y, Z, anything. So we have one more project, one more quiz. So my goal for today was build quiz number 4 and then call it a day, like figure out what we want to do to demonstrate module 4, and then Monday, Wednesday, talk about project 4, kind of working on that. Friday, if we want, next Friday, it's the Friday before Thanksgiving. We could take the afternoon off. We've been working hard. I don't know if you already have travel plans. Like, I wasn't going to be here anyway, but we can figure that out today as we're kind of working on quiz number 4. Sound like a plan? And then module 5, that one's kind of dealer's choice, where come to class, talk through like what you're thinking, what's involved, but we'll get back to that, right? All right. So then we've got, let's make a whole new one. So first step is what kind of concepts and skills are we trying to demonstrate? We can kind of start off with just brainstorming, like what did we cover, what's important, even little things, and then we'll start looking at like how do we demonstrate that with some questions. I like note cards, behind drawing, writing. Yeah, so looking at the rigid body, this can be rigid body. Okay. It feels like we were doing
doing that only for so long that it was well first. Yeah, the very first question was space and so much inside of this. Yeah, ends up being the same topic, different. And that's the nice part about it. Actually, a lot of the other don't matter when you have big reports like that. Yeah, it doesn't have to be really complicated. It's very interesting. Yeah.
All right, so far we had a couple of, and some other things came up, but I wanted to ask, what do we think about these? Impulse momentum, that's like a conceptual thing, but what's the formula, like what's the math behind this of saying like impulse and momentum? What did we use for this? Because it's not F equals MA, right? It was something different. Or is it F equals MA? It's all F equals MA. No. Yeah, so a change in momentum is a force over some time period. So delta mv is F delta t. That's your main like impulse momentum formula. And the nice part whenever you're looking at something like in the case of the boat that hit the bridge, where we were trying to figure out like how do you stop that momentum, there's definitely drag on the boat. There's gravity, there's the buoyancy of the water, but none of those forces are as big as the stopping force during the impact. So that big F delta t, the big impulse, is the only thing that's really like changing momentum for a short period of time. So it's a really useful technique. What about angular momentum? What was the deal with this? Does a force create angular momentum? It depends. Yeah, I like that. Yeah. We need some kind of pivot, right? Like we need something spinning. Okay. So how do we get something to spin faster? What was the deal with that? What is my angular momentum kind of equation?
Well, it would just be the angular version of a standard one. That would be the velocity times the angular velocity.
moment of inertia, angular velocity. Okay, yep.
So that would be, what's it called, I times theta dot?
I theta dot, and that one's h, right? So it could be like if it's a point mass moving around in a circle, it's like mr squared. If you have like distributed mass, we looked at like a sphere, I forget what else, but it'll have some, oh, and a bar, like ml squared over 12, or 2/5 mr squared, 2/3 mr squared, but something. How do I change angular momentum? Can I apply an impulse to it? Some kind of torque, yeah. How does torque relate to angular momentum?
Force applied some distance away from the center of where the thing is.
Okay, so we'll say like the moment is it equal to angular momentum? What is it equal to? Yeah, the change in the angular momentum. So we say like ddt of that. So we looked at a special case with a spring attached to a point where the spring's not creating any torque. So there was no moment, which means angular momentum was constant. Okay. Then other thing I think I saw people kind of writing down. What was that like general work energy form?
Yeah, why the kinetic energy plus potential energy plus
Yep.
force done.
Yeah. So I always use T and V. I know I saw some people in their notes and like, this guy's crazy. I'm gonna write a KE and a PE. You can do that. It's totally fine. Just keep track of what's what. But I'm gonna stay consistent in my crazy world. So kinetic plus potential plus the work done is, what do we get after that? What's the final? What can we set that equal to?
The second kinetic plus second potential.
Yeah. Yeah, some going from 1 to 2. Maybe we did some work on it, or maybe all energy was kind of conserved in a kinetic potential sort of way. So we have that like work energy. Then there were some other things that people, oh yeah, like cross product was one of the skills that we were talking about with we were working on that. Any other things that came up from people? What else was module 4 all about? Yeah. Vectors? Yeah. Yeah, why did we need vectors for stuff? Is energy a vector? No? What do we think? No, definitely not. In the back, there's someone saying, like, definitely not. Like, stop saying it's a vector. So work energy, main benefit is like everything's a scalar. It's always in terms of speed, like distance, like how far something went. It's not talking about like, yeah, like energy is energy. If you have it, then you can use it. What about momentum? Scalar products? Vector? So they've got some magnitude and some direction. So both of these were vector equations. Yeah. Nice. That's a great point to bring up. It's like we were using these new kind of formulas, but we didn't really lose any of that, all that work that we had put into dealing with vectors for F equals MA kind of stuff. Still got to deal with that. Cool. Did I miss anything else? Are we like totally captured? Box. We boxed it up. Cool. All right. Now, next step is we can't do, I mean, technically we probably could have a question that answers everything all in one question, but we're trying to demonstrate some kind of skills, something that we're comfortable with based on our current level of like, I've just been introduced to this topic. This is how I can demonstrate that I learned something along the way. So what are we working on? I'll leave up concept skills so far, and we'll go from there. Questions?
I'm trying to think of some kind of impact.
Yeah.
So like something driving towards something.
Okay. Yeah.
So like I'm thinking back to like the tugboat, like it's hitting something.
Okay. Yeah. Like one of the things we didn't talk about for tugboat is like we could build up here.
Yeah.
So that as it hits it, it starts going up.
Okay.
It's not.
Oh, yeah.
It's not impossible, right?
There was the marble question too.
Yeah, similar. Like
Yeah.
basically build a speed bump.
Okay.
But then you can now hit a concrete speed bump like that.
Yeah.
Not the cargo ship. You might save the bridge, but
Yeah.
it'll be clean enough. AliExpress cargo shipping for the next 6 years. Impulse or like a problem or movement.
Yeah, that's sliding down the wall. I'm trying to change some of that.
Okay. Yeah. Yeah. Sounds like a classic physics problem. Physicists love it. You move so fast as it moves down the wall that it's only actually slide off. They start moving forward. Okay, yeah. Okay, yeah, what would happen? Okay. What's
Well, I guess it would, yeah, it's kind of like basketball.
yeah.
But I guess it would bounce off.
Okay.
Unless it's like, I don't know.
It doesn't have to be the same.
Yeah.
Yeah, I was like, it's pretty good when we got the
Yeah, that's nice. Really good.
So there was one thing came up of like thinking about that ball rolling down the ramp of like, what if it had 2 levels to the table? Like what would happen to its speed? Or we could even look at like what happened after it hit the ground. Like we figured out how far it went, but how fast is it going when it continues that way? Maybe something like that. Another thing, so we were also went back to that like cargo ship and here. Okay. One thing we could imagine is like build a giant concrete structure and use gravity, like change MGH of this boat, like as it goes up this ramp, like how steep would it need to be to stop it? Very much a destructive process. This boat would not survive an impact with a concrete pylon like this, but it would save the bridge. So if that's our only goal, we could do that. We can try to figure something out. Then what were we just talking about? Oh yeah, all right. Then another one came up, like ball's rolling, and then it hits a wall. What's happening there, right? I mean, if it's a point mass, it's like, well, it bounces off the wall. But if it's got angular momentum too, what is there friction on the wall? Like, how do we even like start thinking about that one? Oh, you're just like getting ready. Do some math, stretch out the math elbow. Anything else come up or ideas? What other applications or questions were you thinking about? Yeah.
I was thinking about maybe like a bomb that compresses spray and then like launching an object.
And then launch something, okay. Like a pinball? I do love pinball. I don't know how I never noticed that Willy Brew has pinball machines. They have a Spider-Man one and something else. It was like kind of a newer thing. But anyway, I was like, oh, pinball. So now I got to bring my kids back. So compress it and then launch it off, okay? Yeah, and we could even talk about like if we want to mix and match stuff. We launch it, and again, kind of thinking about like pinball. And it has to go like launches straight out of ramp, and then it's got to go up. So then how far up did it go? I know one year there was the problem that the class came up with was like the same marble problem of rolling down a ramp, but imagining like how high up would you go if you had a mirror of that same ramp on the other side of the table, how high up would you have gone on the other side? And then you could figure out like how long would it take you to stop the marble. I mean, that was kind of outside the scope of what we thought, but this is a cool way to kind of connect potential kinetic changes in momentum all to each other. Other ideas, brainstorms, thoughts? Off the wall, koosh ball, physics. Yeah.
I feel like kind of like the ladder ball where it's the top of the ball, and there's a ball at the end, and see how far the ball goes.
Oh man. Oh yeah, I forgot. Someone else was working on the ladder problem. So as you kind of get down to here, you kick something and send it over. Ooh. Nice multi-physics problem. Well, not multi, I guess mostly rigid body problem, but snapping it down like that. All right, so let's go through, how about like, we'll give thumbs up for like, yes, totally ready for it, or you can do like thumbs to the, like, maybe with help, or thumbs down, like, no, not right now, future work. So number one, thumbs down, thumbs up, how do we feel? Pretty good. Okay, so that one's a maybe. How about number two? Thumbs up, thumbs down, thumbs up. Some maybes. So we'll give this one like, I gotta change my scale. So this one's like 1 check, that one's 2 checks. How about number three? We're rolling and we hit a wall, and then talk about like what's happening after that. Some kind of bounce. Maybe. So we'll say like I don't know. I don't like a check minus system. All right, we'll just do like more checks and less checks. How about number 4 of like maybe some sort of like pinball physics? Like compress a spring, try to get it to launch at something. Question? Oh, sorry, that's all right. Yeah, like we can clarify. Yeah, so thumbs up. Any thumbs down? No? Okay. Back to like 3 checks. How about looking at some kind of like sliding bar mechanism to kick something? Maybe a little bit. Little? All right, so we'll go back to like 1 check. So the main things people, at least from this like pretty rough survey, it's kind of like either something where we're looking at rolling down a ramp and maybe like add an extra step, or thinking of like reversing the ramp, like trying to go up it and have some other kind of like initial energy source rather than just gravity. Any preference? 1 versus 4. Pinball physics versus, I don't know what the marble physics is. That one seems like a solid, like your kid is at the kitchen table just launching marbles off the table. That does seem like my 7-year-old. He would be totally into that kind of activity. It's also probably something like this is, there's one way of testing, I mean, you could use it for a lot of different fruit, but cranberries in particular, one way to test cranberries is, cranberries are red, right? Red or purple? What's a cranberry? Purple? Red? Red. All right. Red. So we got a red cranberry. We roll it down a ramp. Then we choose like a wall. We can choose any angle of the wall that we want. But as it comes off the ramp, it hits this wall, and then it'll bounce off. If it's really bouncy, then it bounces into our save container. So it's like not a mushy cranberry. If it's really mushy, like it kind of splats, it falls down here. And it's super simple, like physics, right? Like you don't need machine learning algorithms or something like testing the consistency of it. Just like bounce it off a wall. If it lands in the bucket, keep it. If it doesn't, throw it out. Kind of cool, right? Yeah, and that's how you can like process cranberries with the same kind of table physics that we were just looking at. And here, it doesn't matter if you send one cranberry at a time or 6,000. Just like dump them all down, have them all hit these things and sort them. Anyway, cranberry. We're coming up. We're gonna have to be using cranberries, and now you can say like, did you know we could create our own quality control cranberry mechanism with coefficient of restitution? We didn't really get too much into coefficient of restitution. That's a good skill to have, but some other time, I don't know, next time. I should add some questions about that, like just coefficient of restitution. I like this one. Personally, I like this one because it's like similar vein, something like in our wheelhouse, but a little different, like a little different flavor of what we've done. If my opinion matters on it. It's your quiz. You have to do it. I just like send it off to you, like good luck. No issues? I'm done. All right. It's been a long week. Let's end it. We got extra time. Give some of the time back because I keep going over. It's always like 2 or 3 minutes, sometimes 5, and 15 minutes early. And just like get outside, get the chills, and then cool. Thanks a lot. We did our work.